A very good morning to everyone. My name is Leon Kenyi. I come from Faculty of Mechanical Engineering Technology, University Malaysia Place. The title of my research is Double Incline Anchor Punch for Trimming of ZSC 590YN Ultra High Strength Steel Sheet. This is my presentation outline today, and we start from introduction. High-strength steel is widely used in various applications in the automotive industry, including the body structure, the chassis of the component. So, the high-strength steel have an excellent strength to weight ratio, which is make it ideal for the lightweight vehicle. The high-strength steel are used at the different critical zones of the vehicle. The purpose is to improve the safety passenger, as the figure show the different category color steel are using at the body structure. The figure show the car part need to be trimmed. Example, a rear period assist, center period assist, rear warehouse, front floor assist, and so on. However, the use of the high-strength steel also presents unique challenges during preparation, especially during the trimming process. For the trimming in the manufacture is critical of automotive components, especially tools made of high-strength steel. Trimming is a shearing process used to remove the scrap from a panel after it has been drawn from a flat metal sheet or blade. For body in white part made from the ultra high strength steel, the finishing process trimming of the part. For the conventional flat punch is a common punch shape used in the trimming process for a variety of the material. As the punch starts to contact an indent, the whole area of the flat punch is in full contact with the workpiece, make it work under significant high localized stress at trimming area, which is will result the high trimming load and reduce the tool performance. This situation is destroyed when the stem part shape is complex, such as have incline or curved shape, where tear crack can happen. The objective is to investigate the trimming performance influenced by the punch shape with different double incline punch compared with the flat punch. The second objective is to analyze the maximum trimming load compared with different double incline punch under a different clearance. And the third, to analyze and justify the shear edge quality that occurs on the workpiece influenced by the double incline punch. For the methodology, the top view are showing the dimension of the workpiece, length of 60 mm and width 40 mm, length of the 10 mm as the scrap part. And the red line is the observation zone for the trim part. For the side view are showing the thickness of the workpiece 1.22 mm. For the next of the methodology, here we can see at the left hand side is the represent the diagram of the trimming process with the punch, clearance between punch and block, blade holder, and the workpiece. At the right hand side is showing the double incline punch. They have a two side with small inclination angle with 5-degree angle, 10-degree angle, and 15-degree angle. For the next of the methodology, the trimming process was carried out using UTM machine with a press force of 250 kN and with a speed of 4 mm per second. This testing machine can record the 4-stroke data of the trimming process. The die set will install at the UTM machine. The different double incline parts can be placed at the upper plate. The blade holder are used for clamp the workpiece with the die, which is complete the set up the mechanical part. After that, select the method from the software and starting to run the experiment. The experiment will be conducted repeat 3 times for each combination of the parameter. For the observation, the shear edge quality are using the digital microscope with 45 times of the manipulation. The figure shows the part of the microscope, specimen placement, and observation zone. The software of the digital microscope can record the dimension based on the shear edge category zone. For the next slide is result and discussion. The figure shows the tremolo with different double inclined punch compared with the flat punch. And here you can see the tremolo of the flat punch is generate 33,000 Newton, which is higher than other double inclined punch. By using the double inclined punch with 5-degree angle, the tremolo is 5,000 Newton. The reduction in maximum tremolo almost 60%. A further reduction in maximum trimming load was obtained when trimming with double inclined punch with 10-degree and 15-degree. This significant reduction in trimming load is achieved through this design with slight inclination at the punch edge. For the flat punch will cut all the scrap area in once, generating an extreme high load for the punch to break the total bonding force in one. Unlike trimming with double inclined punch, the cutting action of the scrap transfer into a localized mode, which is in contact with inclined edge is cut. However, the punch stroke was found in, in proportional with the increased angle of the punch. For the next slide, result and discussion. The bar graph represents the currents influence the various double inclined punch. And here you can see at the current 50%, as the double inclined punch angle increasing, the tremolo become reduced compared with the flat punch. From the observation, the bar graph, the tremolo at the current 50% is higher than current 30%. As the current increase, it possible cause the separation the scrap, produce a high bending moment and crack progression. So it will be affect the shear edge quality. Here, the selection of the stable clearance is important to optimize between double inclined punch. For the next result and discussion, the characteristic of shear edge consists 4 types, which is rollover, burnish, fracture, and burr surface. The shear edge quality observation under the digital microscope. For the A is represent the flat punch, and for the B is represent the double inclined punch with 10-degree angle. The total length for the observation is 40 mm. From the comparison between the flat punch with the double inclined punch with 10-degree angle, the increment of the burnish surface become larger as long as the shear edge by using the double inclined punch with 10-degree angle. The double inclined punch with 10-degree angle created a large smooth cutting area, and increment of the burnish surface can be seen at the end of the section of the trimming area. For the conclusion, the investigation on the changing of the punch shape is important to study for the understanding of proper mechanism to minimize and maximum the tremulum and increase the shear edge quality. A significant reduction of the maximum tremulum can be achieved by slightly increasing the punch edge with respect to tremuline. Increasing in clearance is however lead to bend of the workpiece prior to separation of the scrap, which is in the result in the poor shear edge. So, a stable selection of the clearance optimize the result between of the double incline punch with the shear edge quality is important. Thank you.